Well, hello class, welcome to the week 2 lab 3 review. Hope you guys had a great weekend. Just wanted to take a moment to go over the solutions for the week 2 lab 3 as we progress through the scenario for I am informant with our continuous case investigation. We start jumping more into the registry this week and looking at more behaviors. Want to encourage you all and appreciate you all with your questions that you have sent me over the past couple of days. However, I do want to encourage you to start these labs early on in the week, okay? And I am looking to see that you are using the Help Your Neighbor forum, okay? So the Help Your Neighbor forum is there for a reason, to help you folks collaborate with one another. I do want to see that collaboration. It helps me also understand if there are questions throughout the week. I know I've heard from several of you here on Sunday night, and I was the first time I had heard, you were having maybe a struggle or a challenge with the lab. I didn't see any collaboration much this past week. There was a question once or twice in the forum, but I did not see much in the way of emails or messages to me directly or questions being asked inside of the forum. And so what that tells me is either A, there is no issue, there is no challenge going on, or possibly that we're just maybe waiting till later in the week to put our lab reports together. And I get it, things come up. Life is busy, life is full for all of us. You're juggling school, work, some of you family. However, you are in a graduate class, so the expectation is very high. This class requires a lot of time, a lot of commitment. It's not something that you can just wait to do to the last minute, okay? So please work diligently as we get into week 3. The labs will become more challenging, and this is maybe new material to some. And as I said last week in the video, there is an expectation that you come into this program with some knowledge the forensics background. However, I understand that this either A, might be new to you, or number 2, it may have just been a while since you've actually dove into the forensics this deep, going into the registry and finding out more of the in-depth artifacts. So with that, I encourage you also to go back out, as you see here in Canvas. I did post an announcement just a couple of days ago recommending some other books that you may want to look at, okay? So under the supplemental readings, one in particular that I would highly recommend for you to look at is this Windows for Registry Forensics by Harlan Carvey. It's got a lot of great resources in there, really a deep dive into the registry. This would be a supplemental text that I would recommend to you. It is available through the online Champlain Library. And also, again, with it being a graduate course, there is quite a bit of independent research that you are expected to undergo. And I do expect you to go out and research, and I will certainly point you in the right direction and give you hints. But I want you to have some fun with the challenge of finding the answer and really doing some independent research for this case. And this type of mentality will follow you through the rest of this program. And also, just one last time, this group collaboration, I strongly encourage that you leverage each other as well this semester as we go through this continuous case investigation. Okay, so let's jump out into the questions for week 2, and let's just see what informant has been up to this week. You guys have done a great job. I've had a chance to look over a few of your lab reports, and I want to encourage you to stay in the fight and continue to press forward. We are into week 3. We'll be at the halfway mark before you know it, and let's just keep pressing forward and giving it our best. I know you guys have got a lot going on, but I know you can do this and have a lot of fun hopefully in the process. Alright, so the week 2 lab 3 gets us into a little bit more in depth as we start looking at logs and looking at browser history and things of that nature, like prefetch, and looking at some specific artifacts that we find with Windows 7 in the registry. So question 1 says, list the application execution logs. Okay, looking for the path, execution time, and the execution count. Now there's a couple of different ways that we could go about this. Okay, What I would suggest is going through and actually looking at the prefetch, okay, the prefetch folder. So what is prefetch? Well, prefetching is a process in which the operating system loads key pieces of data and code from disk into memory before it's actually needed. Okay, so the prefetch directory is actually populated once an application is executed, and this is maybe a reason why it would be a good idea to grab the contents of the prefetch directory manually before performing any type of incident response of a machine, as the contents of prefetch can be considered fairly volatile. So if you go in and pull the power plug on a system, you may lose some of that information because prefetch is volatile. But prefetch is an area that you can look, and when you look at Windows 7, prefetch, which is now called superfetch, was improved starting with Windows 7, Windows 8, by loading the majority of the files and data needed by a process into memory, and when it isn't needed, the prefetched information is written out to the page file. Okay, so prefetch, superfetch, they analyze applications a user uses to include information about how often a program is used and the time it is most likely to be used. Okay, now when you go out to look at this information, we look at the output, we have several tools. You can Google and type in prefetch parser. One that I have found that you may also have found as well is just that, the prefetch parser output. Okay, it's a relatively easy program to run. When you execute it, you type in the case name. For this particular one here, I just put in data leakage 2017, the prefetch directory, which for me was on the desktop. Now, you're like, okay, where is the actual prefetch files? Glad you asked. So FTK Imager is where I'm at, and I'm at the root, and I go to Windows, and I go to prefetch, and as we've done before, right click, export those files. Okay, so I put those on my desktop. Here's my prefetch parser. Okay, so this is the output directory. I brought them in, and this is where the report would be written. Okay, it will also allow you to select between several views, right? So if you were looking at an old XP system, you could go that route, or select Vista or Windows 7 prefetch. What I like about this tool is it shows the last execution date and the total number of executions, in addition to allowing you to actually click on a prefetch link, a .pf extension, and see the file handles that were actually stored within. Okay, so if we look at Windows prefetch here, and we're going to look at the executable files, and again, this is just one way that we could we could look at this. Okay, so what we're looking for are the executed time, the execution path, okay, the count, and the source. Okay, so let's just take a look at one of these. For example, eraser.exe. Okay, number of executions once. Okay, execution time March 25th, 2015. Okay, so we continue to go down the line, and we see Google Drive. Okay, executed twice, and on down the line. Okay, Internet Explorer executed 14 times. Okay, so once we click on one of the .pf links here from the prefetch report that's generated by the prefetch parser, okay, it's going to open a new window listing the file folders and devices used when the program was executed. Now, even if the file or the folder was used in independent subsequent executions of the application, there will still be evidence stored in the single PF file. So we can use this tool to parse out the files referenced inside of the prefetch file. So we can see, looking here, pretty simplistic view. Now I can also output this out to a CSV. Okay, So there's the prefetch files. I can put this out to a CSV if I wanted to put this in a spreadsheet format. So there's quite a few. For the application execution logs, quite a few there when we look at the prefetch. Okay, so prefetch is one way that we could go about this. Now, some of you may have also gone into the registry and you may have looked inside of the software hive as well. That is certainly another way that we could go about this is in looking at the software hive. But I wanted to at least introduce you to the prefetch and actually show you that as one avenue that you could look at. Okay, so we'll take a look at the next question, which asks us about particular logs. So we're looking at the traces about system on-off, user log on, log off. And this is just looking at the time frame between 9 a.m. and 6 p.m., so the work hours for informant. Okay. Now, what's important to keep in mind here is when we look at event logs, what they help us do is really get down and start tracking some usage for the actual subject of our investigation. Now, there are several types of event logs that we could look at. You have your security logs, you have your system logs, application, and custom. Now, when we look at security logs, those are typically going to give us the information that we want here, recording the access control, security settings. You start getting into system, that's going to be more about events related to Windows services, and then application logs are going to be software events that's not tied to the operating system. So like if a SQL server were to fail to access a database, so specific to the application. So the event logs typically are in the .evtx format, okay, and the format of the logs actually changed as we get into the newer versions of Windows. So they carry that .evtx file extension and are typically stored in the XML format, and that really helps us when we want to deconstruct the logs themselves, makes them much easier to actually break apart. A lot of logs, as we increase versions of Windows and we go up, starting with 7 up to where we are now with 10, the number of logs definitely continues to increase. You know, new logs means new events, giving us a better view than really we've ever had before in the forensic industry into the running processes on the system. So a lot of good information can actually be gleaned from looking at event logs. So where do we find event logs? Okay, so I go back to FTK Imager. Okay, so I'm going to be under root, and under root under system 32, under Windows and then system 32. Okay, and when I get to system 32, I'm actually going to go out to my Win EVT. So there's Win EVT and there's logs, and as before I'm going to right click and export that. So now we get to how do we view our event logs. Now you can go out and Google Windows Event Log Viewer, okay, and you can download something of your choosing. One that I have downloaded to use is this free tool that's our Event Log Explorer. Okay, so Event Log Explorer, you can actually go out and actually download that yourself, eventlogxp.com, and it's a free license if you use it for home purposes. Okay. Another site that I want to bring your attention to is breaking down the actual code, right? So breaking down what the IDs are for these events, and this is just a quick Google. So this is what I am encouraging you folks to do for this independent research. Okay, so you're given a question in the investigation. Okay, you have to go out and find the answer, find out how you can actually parse out and view the data. Okay, so all that I've done here is just showing you open source research. Number one, I had to go out and actually find where my event logs were stored. Number two, I had to actually then go and find something that would allow me to view those EVTX, those event logs. And then number three, trying to break down what some of these codes are. So let me open up my Event Log Explorer. This is the interface here. So I file, and I actually go ahead and open up a log file. Okay, and we're just doing standard. and this is where I saved it on my desktop when I exported it from FTK Amateur. Okay, so if I go to logs, it's going to say what type of log. Well, we have application, we have hardware events. I'm not interested in any of those. I'm actually going to go down and open up my security logs, okay, which is what I have here. And the question asks us, list all traces about system on off in the user log on log off. Okay, so I go back to my event log explorer, and so we look at these particular dates and times, okay, and we see the categories given to us, but I like to correlate this category to the actual events that we have here. Okay, so correlating what we have here with the category, okay, with the actual event IDs. Okay, so when we look at the event IDs, a couple that stands out are 4624, okay, 4624 and subsequently 4625 you should see as well at some point. But 4624 typically a successful logon. Okay, so what I'm doing there is if I go back out to my web browser and I scroll down and I do 4624, maybe not showing up on this one. I don't know if this particular one goes down as quite as far. Let's see. We can certainly go out and Google some more of these. Security events. I was in the wrong link there. There's our 47s. Okay, so let's see if 4624. There we go. So 4624 under the subcategory of log on, account was successfully logged on. 4625 would be an account failed to log on. Okay, and 4634 would be logging off. Okay, so successful log off. So if I go back to my case here and look at inside of Event Log Explorer, I can see 4624, so 1118. This would have been a successful logon. Gives you the SID, the domain, gives you the logon type as well. Okay, timestamp, event ID, and the computer. So all very, very helpful information for us to be able to look at. The timestamp is going to be when the actual event was triggered. That's going to be displayed in the local system time. The user, the account that actually triggered the event. Okay. Bring this portion up here. So a lot of good information here. So again, 4624 giving us a successful logon. Okay. The computer is going to be the name of the computer where the event occurred. And we also see the event ID again, 4624. So quite a bit of information there that's given to us. Now, the logon code types, all right? So we see a logon code type here of 5. Okay, so that's typically going to be a Windows service logon. Okay, that's non-interactive. So logon events can give us very specific information regarding the nature of the account authorization, how the actual user logged in. So let's take a look at maybe the special logon, 4672. Actually, I'm just going through a couple of these to see if there's any differences. That's a 5 as well for logon type. Logon type 5. So logon type 2 would be logon via the console, actually using the keyboard. Logon 3 would be network logon, but here we have a Windows service logon. Okay, so let's actually research a little bit of that. Okay, so we look at the sessions. Let's go out to Google or do some research. A good site is Windows Security. It's actually a good article on logon types. And so logon type 5, service. Similar to scheduled task, each service is configured to run as a specified user account. So when a service starts, Windows first creates a logon session for the specified user account. Okay, failed logon events with logon type 5 usually indicate the password of an account has been changed without updating the service. So this is less likely because creating a new service or editing an existing service by default requires membership. So that's what logon type 5 means. Alright, so this gives you more information about the different types of logons. So again, the question asking you, just giving a sequence or a running list of system on, off, and the user log on, log off. So we go back to the event log. Okay, so we have this here, we're under security. And the very last one here, informant, and we go up to the top at 11:31 and we see a service shutdown. Okay, so the event IDs for Windows is what we're looking at here, just correlating those categories with the actual event ID. Windows starting up 4608 and 1100, as we see there, is a service shutdown. Okay, and then 4624, successful log on. Okay, and 4634, log off. So these are log offs. So that logon type there is a 7, so we go back and look at the list. That's an unlock. And then another one to be aware of is 4625. If you saw that, that would be a logon failure. And then 4647 would be the user initiating the log off process. So again, that's all the question was asking you there, just under the security event logs, being able to provide a comprehensive list of those types of data. Log on, log off, system on, system off. Okay, so our next question asks us to look at web browser content. So we start jumping into web browsers, and this is where we can start getting a lot of good information from browser forensics. It's really important for us to understand that each respective browser gives us different information, and the information may be stored in different formats. An example of that would be Chrome. Chrome would be stored more in your traditional SQLite database formats, and that makes things a lot easier for us to view as investigators. But there's importance to understand also the location of data, as well as what actually can be retained by each respective browser, such as Internet Explorer, Edge, Chrome, Firefox. Each one of these browsers will provide or yield us different information based on the user's actual activity. So when we look at the browser artifacts, this is where we really can start finding a lot of great information and building together really just a profile of the user's behavior, things they're interested in, and it's just a critical skill for us because it gives us such good information about what's frequently done by a user. So think about the internet and how often you and I use that, and that's one of the most frequent user activities, and looking at the browsers are the key windows, if you will, into understanding the access and understanding if there's any type of misuse going on the case of the subject, and the internet activity alone may give us that key piece of evidence that we're looking for. A frequent example, typically when we look at internet or browser artifacts, is really looking at the history for maybe local file access or browsing of network shares or even external cloud accounts like your Dropboxes, Google Drive, things of that nature. So the first question here in the Lab 3 asks us first, what is the web browser? What are the web browsers that are used? So I keep going back to FTK Imager because I think it's a great way to walk the neighborhood once again and see exactly what the user's up to. So I use FTK Imager quite often to serve as my jumping off point. And so here I am actually going to be under my users directory and under informant. Okay, so under informant I go to app data and I just start scrolling through and looking to see if anything stands out as a common browser. Well, I know Google makes a browser, so I look at Google and I see that there's a Chrome. And because we know this is a Windows machine, we go to Microsoft and we would see more than likely Internet Explorer. And so those are two that I know that stand out. And from there, I would actually go to the registry hive and actually look at the, or I'm sorry, go to the software hive under Registry Explorer. And let's just take a look at the specific versions, right? Because different versions of a browser may provide different artifacts, and we may need to understand what those might yield, what those limitations may be. So under the Registry Explorer, again, you can use RegRipper, or you can use any other, tool that you'd like to use, Registry Viewer, inside of the VDI. So we're under Registry Explorer. I go to Microsoft because I'm looking first at Internet Explorer. And the version is what I want to find out. I want to know what version it is that I'm looking at. So under Microsoft, and I scroll down to Internet Explorer. And the version of this SVC version you see here, 11.0.9600. Okay, so that's the updated version of at least IE 11. Okay, so what about Google Chrome? Well, let's take a look at another avenue here. So let's go, I've got RegRipper open, and I just brought in the software hive there. And I just did a quick search for Chrome, and for this particular version, we're looking at version 41.0.2272.101. Okay, so that's the browsers that we're looking for. Now, what about the directory or the file paths related to the web browsing history? That's our next question. And so for that, I'm actually just going to go back to FTK Imager, and again, just identifying the file paths that are related to the web browser history. So we've identified, we've got Chrome and Internet Explorer. And so I'm going to go back to my users. Okay, so here's Internet Explorer under informant. Okay, and we're under the informant directory, and we are under app data local Microsoft. Okay, and let's take a look first at Internet Explorer. Let me actually back out here to show you exactly how I got there. So let's close some of these down. Alright, so informant, app data, and then we'll go down to local, and under local we'll go to Microsoft, and then under Microsoft we'll go down to Windows, and then you will see history. Okay, and the history that we're looking at here, we can actually export. Now, of course, if you were to bring this image, the EO1, into a tool like the full version of FTK or Encase, or into Autopsy, for example, then obviously this would parse things out nicely for you. But again, good to know where this is located in case you needed to manually examine this information. And I go back out. Okay, and so now I will go and look for other locations where I could possibly find history information. I could go out to local Microsoft Windows. I also may want to look at temporary internet files. Okay, and then I may want to go out and look at cookies. So history, temporary internet files, and cookies. These are all areas inside of Microsoft Internet Explorer where I would find data related to web browser history. So Microsoft, Windows, and we go out to cookies. Okay, And for this particular version, I need to go back to roaming. So instead of being under local, I'm going to go back out to roaming. So let's shut up local here and let's go to roaming. Okay, and then once I'm under roaming, I'll go to Microsoft. And then we're going to look again under Windows. And then temporary internet files. I'm sorry, cookies. And we would have our information pertaining to cookies there. Now again, these are just locations. We're identifying the directory of the file paths related to the web browser history. Okay, and we could export these out if we'd like to, and bring those into another program to view. So then we move on to what websites were being accessed. One of the things that I want to keep you informed of and make you aware of is the typed URLs feature. So when we look at Internet Explorer specifically, if I go back to my intusers.dat, and let me actually bring this into Registry Explorer. We're going to load an offline Hive and bring in our intuser.dat. Okay. Okay, so under intuser.dat, we'll go to software and then Microsoft and then Internet Explorer. And then under Internet Explorer, you will see an entry that is labeled typed URLs. Okay, so these are a few that were typed in: Bing.com, Google.com, Microsoft.com. This is a great registry key. People who search the internet or go to a site maybe claim, hey, I didn't do this. The site popped up, right? Or it just magically appeared. This particular key is present for us, and it's actually modified when the user types the website directly into the URL bar, or if they do a copy and paste into the URL bar for a specific website. So that's something to keep in mind. So if we go back out and we look at the actual websites that were being accessed, okay, some things to consider, and there were quite a few. We actually back out of this. The microscopic registry explorer, every time I open up a Hive, it actually goes back to microscopic view, so I have to zoom in there for you. So for there, we can go back out and look at our history, right, for the browser history, our cache. And so what I'd like to do for this instance is actually look at a program like Autopsy. I'm showing you just another free open source tool that you can use. And so with Autopsy, it's a free tool that allows us to actually parse data from the actual image that we are provided. So the EO1 for the PC associated with Informant's computer. So I create a new case, and we'll just call this data leak 2017. And I need to choose a directory. I'm just going to go ahead and keep this all in the same folder that I've been working with just for simplicity. And hit next. And we'll just call this case number Informant 1. Put your name or your initials for the examiner. Okay, so it's going to go ahead and create the case database, and then it's going to come back and say, provide me with the evidence that you would like for me to analyze. And again, this is Autopsy 4.4.0, and it says select type of data source. I'm going to select a disk image since we were dealing with the EO1. We had established earlier on in our first lab that this data set is in fact under UTC-5 America, New York. We hit browse, and I'm going to bring in that EO1. And then it says, would you like for me to ignore orphan files and FAT file systems? So we're not dealing with a FAT file system here, we're dealing with NTFS. So we'll just go ahead and hit next and not select that. And then this is where you can save time or add time to the parsing. Okay, and it gives you options to select different types of ingest models. Okay, so we're not dealing with an Android device, so we'll go ahead and unclick this. We'll get rid of virtual machine extractor. And I'll leave these. The more of these you have selected, the more time that it takes for the image to actually parse out the data. So we'll hit next, and that'll start running. And then as it starts to run, you will start seeing data populate inside of autopsy. Okay, here on our left side in our evidence tree. So we'll let that run for a few moments, and we'll come back and take a look and see what data was in fact parsed out using autopsy, or using whatever tool that you'd like to use, whether it's EnCase or even FTK. And so I hit finish, and it says data sources have been added to the local database. Files are being analyzed. So files are being analyzed. It shows you here in the bottom right the status, and then you'll start seeing data populate here, and we'll take a look at that. Okay, so autopsy is starting to parse out the data and show us web history information that we can see here. I wanted to actually bring your attention to one other artifact that we looked at just a few minutes ago inside of FTK Imager, and we were just doing a manual walkthrough of the history. So there is this artifact when we started with Internet Explorer 10. It was called the index.dat, okay, that most people in the industry would be familiar with for looking at web history information manually. So we got into Internet Explorer 11 and newer versions, and we look at now this new file called webcache v.dat, okay, and that's basically a consolidation of a lot of data that was previously stored in what was known as the index.dat. And it basically gives us any information pertaining to specifically to Internet Explorer data from history, cache, cookies, things of that nature. The trick to it is actually being able to view this content. Okay, so we have autopsy running, or maybe you're using EnCase or you're using FTK, and you're able to see that data being parsed out. But as we all know, and as we have seen in our discussion this week and last week, is really it's important that we validate our evidence, right? That we're understanding what our tool is telling us. And so doing a manual review of this is something that I would encourage you to do, and also it introduces you to another tool set. So there is a tool that you can download that will allow you to go out and actually view this particular file. Okay, now it's a free tool set by the company called Nirsoft, N-I-R-S-O-F-T. Okay, and Nirsoft allows you to actually download what is called the ESE database viewer. Okay, so if you go out to Nirsoft or you Google Nirsoft ESE database, this is freeware, and allows you to display the data that's stored inside of this ESE, this extensible storage engine, and this allows you to parse out this data manually in a consumable format so that you can actually look at the data in a logical way. Alright, so let me open up Nirsoft, okay, and I'm going to bring in that file, that webcache v.dat. So let's first find that. So under the user directory, under informant, I go down to Microsoft, okay, and then down to Windows. And once I'm in Windows, I'm not going to go to history. I'm actually going to scroll down to what is called webcache, okay, and I'm looking for the .dat, and you can see the size difference here between the others. And so I'm actually going to export that. And that is done. And now I'm going to go over to Nirsoft, and we're going to open that .dat. Open ESE database file. Okay, so we start looking through the containers, and there's quite a few here, and I don't really have a key for you as to where to actually start. This is just where open source tools like this, as they have new versions, you have to look through and kind of determine what data is being provided to you and try to validate that. Previous versions actually had a name column that would actually tell you what data was actually given to you. That's all been merged with the latest version of this NurseSoft tool, this ESED database viewer. I'm going to start going through just logically and going from kind of low to high, looking at the containers. So container 2, not a whole lot of information. Well, I have to expand actually. And so this is showing me these are sites that were visited. Okay, so this is showing us some information potentially regarding sites visited. Now, one of the things to keep in mind as we break this down, so the container ID that we see here, that's the identifier for each table assigned to that Internet Explorer artifact. The last access time, okay, we look at the access times here. Now, that's actually going to be the last update time for the table. And again, the actual name is going to be site visited for the URL. Now, the directory information in previous version was actually provided to you, and it's actually now all merged together. As we can see here, this is actually showing us local files that were actually accessed on the actual machine. Okay. So as we break up the time here, the modified time, that's going to be the last access time of the object that's actually referenced in the URL field. Okay, so that's going to give us the first time a given object was accessed. The access time is going to be the last time a given object was accessed. So modified time, once again, is the first time that the given object was accessed. Access time is going to be the last time a given object was accessed. And then you have your counts, that's your access counts that tracks the number of times the object in the URL field has been accessed. So let's take a look at some others. Let's go down to 3. And this is our cookie storage. Okay, so let's go down to let's go to 6, and these are external URLs visited. And you can click on each one of these records. So let's take a look at one that may catch our eye. USB history viewing. We'll click on that, and we can get a more localized view as to what is going on here. Okay, so our time though is kind of messy here, so I double click and I actually am looking at 64-bit time, and there are tools that you can use to decode this. However, ESC Database View being a free tool, it does a great job at actually allowing you to detect that. So I go to Options and I will say Auto Detect 64-bit date and time value. Okay, and I can select that option, and then now we're looking at something that's much easier to work with here. So that's a look at some of our internet history specific to Internet Explorer. And again, once your image is parsed using whatever tool, autopsy, Encase, or FTK, you'll be able to do a deeper dive and navigate easier through looking at the actual URLs visited by informant. So what I have here is autopsy, and showing me just an overview of the parsed out web pages that were detected by autopsy through the EO1. I want to jump to Google Chrome, since this was the other browser that we had looked at. Now Chrome data is actually detected here. As you can see, it basically puts everything together in one shot on our evidence tree inside of autopsy, Internet Explorer, and Chrome. But I wanted to introduce to you once again another tool that you can look at to bring in Chrome data, and that is a tool called Chrome Forensics. This is a free tool that is made available through Wonware, W-O-A-N, where. So we'll just go out to Google. This will be another one that you may want to add to your arsenal, to your tool bag. So this is Wonware Chrome Forensics, and you just want to download that. Nice little interface, gives you a good look at kind of like what we saw with the NurseSoft tool, but this is specific to Chrome, and this gives us a chance to look at specific data that is under Google Chrome. I like the layout of this. I like the tabs. There is another NERSoft tool as well that is actually called Chrome History View, so you can kind of pick your tool that you would like to use, maybe to verify if you want to step outside of the traditional forensic suites like FTK or Encase. So Chrome Forensics, again, great free tool, parses out several of the more important Google Chrome databases. As I said earlier, Chrome stores many of their artifacts in database views, which makes it easier for us to preview the data like history, cookies, top sites, website data. Okay, Chrome Forensics does not, though, provide the page refer. Okay, the visit from field, the visit duration, or the page transition. Okay, so it's actually only pulling data from the history database. Now that information can be gathered by opening up the database in an external SQLite viewer. But for all intents and purposes, what we're looking at here, this is just another way for us to go through and look at the history from Chrome. I got here by, once again, FTK Imager, and I'm under my user, under informant, under the informant directory, under app data and local, and then under Chrome, user data. And then once I get down to user data, I then go out to my default and history, and that gives me the access to that particular file. So under user data and history, and I actually was able to export that. So let's just actually open this up here, and there's my history right there. So I exported that and brought that into Chrome Forensics, so file, load files. And keyword search terms, I like how this tabs this out nicely for us as well. Last visited time and search terms that were entered into Google there. System cleaner, a lot going on here. How to delete data. Okay, this is the good smoking gun evidence that we're looking for against informants. So that's a little bit on the browser side. Forensics, just kind of a high overview. Lots of great tools out there to validate against your commercial tools. Just wanted to show you a few of those from NERSoft and the one that we have here for Chrome, Chrome Forensics. So let's go back to the questions. So we've looked at browsers that were used. We've looked at paths and websites that were being accessed, and looking at the searched keywords using the web browsers. Okay, so we took a look a little bit of that here inside of Chrome Forensics, and that's also going to be present for us inside of Autopsy, both in web search. Okay, we can go that route, but then also under web history, if we scroll over and we look at the title, this is going to be the type of information that we're looking for. For example, inside of Autopsy, if you are using that, if I were to how to delete data, question might be, how do you know, or where does this exist on the actual drive itself? Okay, and so once you look at how to delete data, you click on that. Here are the results. Here's the source file path under that user's directory, app data, local, Google, Chrome user, and then would be somewhat different, obviously, if he was using Internet Explorer to do some of this. Much of the data that was searched for actually was under Chrome for this particular user, so far as the keyword searches. Okay, moving on, we see the next question is list all search keywords using web browser, so we just looked at that. Now this other artifact for number 7, listing user keywords at the search bar in Windows Explorer, and this was a question that came up during the Help Your Neighbor session this past week. So what we look for here is a new artifact that shows up inside of Windows 7, okay, and it's called the word will query. Okay, the word will query is going to give us a list of information or data that was actually input under the start menu under search. Okay, so the search query can be entered into the start menu, and that's what this artifact is going to actually glean for us. Now we're going to find this under the ntuser.dat to find out exactly what the user is searching for. Now I had pointed to you from some of those that asked, where is this located? How do I know this is an ntuser.dat? Well, under the modules I did provide you this poster for the SANS poster, and the word will query is actually located or referenced at least inside of this poster. Okay, so let me actually zoom in here for us, and we're looking for the word will query, and again that's intuser.dat, and it's under here under our search word will query. So we're in the gray section here under the section of deleted file or file knowledge. Intuser.dat, software, Microsoft Windows current version, Explorer, again keywords that are actually listed here that the user would have searched for. So I actually threw this into Redripper, okay, and here's my intuser.dat Redripper report, and I just did a search for word will query, and it shows one term as secret that was actually listed there. So we're looking for secret as a keyword that was actually searched for in the Windows Explorer search bar. The next question asks what application was used for email communication. What application was used for email communication? Alright, so for there we can go back to, again, it's asking about a program, so we're looking for software if we're in the registry, right? And we go back out to our software hive, and I'm actually in Redripper now just to make things easier. However, you could actually still go out into FTK Imager again. Okay, so I see Outlook as I know is 1, and it populates for me IM.informant or im.informant at nist.gov. Okay, so here is some information referencing that particular account. And then we can go under software as well. Okay, so if we open up the software hive or the software report, I can actually even do a search for email. Okay, so nothing there. Let's take a look at Outlook. Okay, so Microsoft Outlook. There's our version. Alright, so the actual email communication we're looking at is Outlook 2013 specifically. And if we were to open this up inside of Registry Explorer, let's actually clean this up quite a bit. And let's unload all of these hives so we can load a new one. I had quite a few open there. And we'll file, open a offline hive, and we'll go to our software. And let's just walk through this. So inside of software, taking just a moment to load here. It's always the fun of doing live demos. You're at the mercy of a tool and the speed and performance. There we are. Okay, so we go out to software and we'll open this up, and we're going to be under class, or actually under clients. I would actually recommend you start under clients. You can go classes as well under mail too, but clients is really more all-encompassing because it's not specific to a vendor here. I then go to mail, okay, and I see Windows Mail and I see Microsoft Outlook, okay. So the application that was used would have been Microsoft Outlook, okay, and we click on that and we can actually take a look at a couple of other different items under Microsoft Outlook, but that's the big idea, is just to know what was actually used so we can actually start looking for artifacts related to Outlook, such as a PST file. And then there is Windows Mail there as well. Okay, and the next question says, where is the email file located? Okay, so we actually just answered that prior to going into the registry viewer. Here is actually under FTK Imager. We drilled down and we found it under the users informant app data local Microsoft Outlook, and we can see there is the .ost there, and that is where the email file is located. And from there, what was the email account used? Well, this is also answered there as well. This is the im.informant at nist.gov. Okay, so we answered quite a few questions just by looking at
that data inside of FTK Imager. And then lastly, list all emails of the suspect. Okay, if possible, identify deleted emails. You can identify the items such as timestamp from, to. So this is a little bit of a challenging question. Okay, so what we want to look at here is examining actually the OST file only. Okay, so we're looking at the OST file, and there's a couple different ways that we can actually go and to find this particular data. So we look at the .ost that we found inside of FTK Imager to start looking at the emails, and the question again just asks us to bring down and bring to light the emails of the subject here for Mr. Informant. Okay, so there's quite a few ways we can do that. Maybe you already have a viewer, an email client on your host, and you want to bring this in. I recommend downloading something separate so you don't get anything mixed up. One of those tools is from a group called the Nucleus Technologies. It's called the Kernel OST Viewer, and it's very easy to download. It's about 50 megs, and it's one that I would recommend as a starting point, but there are certainly other ones. Mozilla Thunderbird is another one that you can use as well. So all I'm doing is going back out, doing the same thing that we've been doing throughout this investigation so far, again using FTK Imager in this instance, and I'm going to take out that .ost and just export that and open up then our kernel OST viewer file, and I'm going to actually open a new OST. I'm importing it in. Okay, so let's just start walking through some of this to find out exactly what our guy has been up to on the email traffic. Okay, and so we start up and we look at initially in the inbox. So we'll start there. I'm in the deleted items now. Let's go to inbox now, and we see this traffic between the subject and then the spy.conspirator. Okay, so we start off at the very beginning here, just going in chronological order, and we see hello, I am, and this again is just under the inbox. Okay, and then we can go to the sent items as well. Okay, and the red here, obviously, as we are typically accustomed to seeing in forensic programs, means deleted. And we see now some sharing, possibly some data exfil of some items that might be going out. Okay, so this is just showing you how to bring in an OST into an external program, and then the deleted items, we can actually look at all of those together, and we see that the Google Drive possibly was used to do some exfil, so that would be another lead that we want to cut to find some additional information. So here we have an attachment that was included. All right, and some of the metadata associated with that. So I do like this particular program, the OST viewer. And let's take a look at one other. So we have the 3/23/2015. Let's go back to that. 1638. So this was deleted. And let's take a look and see what actually shows up here. Appears to be an audio file for those of you that might be Frozen fans. And again, this is just coming from recovered from the unused area of that OST file. So that's a wrap for us on the review of week 2 lab 3. So we're starting to get more into the weeds of the user activity. Hope you found this helpful as we looked at some external tools. Continue to encourage you folks to collaborate with each other in the weekly forums, and certainly reach out to me with any questions. But a lot of independent research here. Also, I hope the Registry Forensics book that you guys are looking at that as well as a supplement to your research for this case. So that's a wrap for this week. Let me know if you folks have any questions, and I look forward to collaborating with you all as we start week number 3. Take care, folks.